this video, I want to discuss permutations and how they are related to counting. A permutation is the rearrangement of objects into distinguishable sequences. Each unique ordering we have is called a permutation. And a very important property of permutations is that order matters. Changing the order of the sequence changes the actual sequence. Before we look at actual permutations, let's discuss the fundamental counting principle. The fundamental counting principle is a way of counting the number of permutations or arrangements of a number of objects. Let's suppose an event, capital M, can occur little m ways. An event, capital N, can occur little n ways. The fundamental counting principle then says that event M followed by event N can occur in m times n ways. So let's look at some examples of this. How many different initials are possible for people who have a first, middle, and last name using the American alphabet? So here I have 3 events that I want to consider: the first name, the middle name, and the last name. There are 26 letters in the American alphabet, so there are 26 possible first initials. There are also 26 possible middle and 26 possible last initial, since it is okay to repeat these letters. So we would multiply 26 times 26 times 26, or 26 cubed. My next example: how many different ways can a baseball manager arrange a batting order of 9 players? So here I have 3, 4, 5, 6, 7, 8, and then 9. And we want to arrange the batting order. There are 9 possible players that could bat first, so we have a 9 there. For the second one, we need an 8, since we cannot let the same person bat twice. We're down to 8 people. The third one would be 7, and then we keep going like this: 6, 5, 4, 3, 2, and 1. So the answer would be 9 factorial. So let's try to generalize this idea. I have n objects and I want to order r of them. If each object can be repeated, then we're looking at something of the form n to the r. Like our first example, we had 26 letters. We needed to select 3 of them, and we could repeat, so we had 26 cubed. If the object cannot be repeated, we actually have this formula here: n factorial divided by n minus r factorial. We factorial all of the number of objects, and then we essentially are going to remove the number of ones that we don't want. And this actually has notation NPR. So this is the actual permutation arrangement for objects that cannot be repeated. Let's suppose there are 3 people that need to give presentations next week. In how many ways can we arrange the order in which these people will speak? Well, we have 3 people, and we need to pick all 3 of them. So using my formula, since we cannot repeat, 3 factorial over 3 minus 3 factorial, or 3 factorial over 0 factorial. We've already said that 0 factorial is 1 in a previous video, and 3 factorial is 6. So we have 6 ways to arrange this. Let's suppose there are 5 people that need to give presentations, but only 2 will be selected to speak next week. In how many ways can this be arranged? So this time we have 5 people, but we only need to pick 2 of them. So we're going to have 5p2. That would be 5 factorial over 5 minus 2 factorial. In other words, 5 factorial over 3 factorial. If I write this out, we have 5, 4, 3, 2, 1 over 3, 2, 1. And we can cancel appropriately in this fraction. We end up with 5 times 4, or 20. On the other hand, if we used our fundamental counting principle rather than this permutation rule, there are 5 people we could have picked to present first. We're now down to 4 to present second, and we get the exact same result.